Hello everyone, Jim Hannon here. Bringing up my final image from the other night, rough image. Before I get to that, I just show you this is my wallpaper, and this is an image taken of the object M17 that's I used my wallpaper on my screen. It's a little better image than the one I'm going to show you that I finished up from the other night. This was taken a number of years ago at a dark sky location, so the image tends to be a bit better. The object is an emission nebula, hydrogen alpha, and notice I said hydrogen alpha in the filters I have, and it helps bring out that red gas material there. That material is actually blowing off from exploded stars and forms stars just like our sun. Our sun is a second generation star that's formed from material like this that's been blown off into space from supernova, and we'll talk a little bit more about that when we look at the image that I got the other night. I processed it, and this is the result. Let me see, we got this centered here. It's a bit better. Okay, this is the processed image from the other night that you saw me working on when I gave you the tour of the telescope and the imaging. There's the bright star 52 Cygni, and of course the nebula. And notice now we have a blue-red image in color. And as I mentioned in those other videos, this camera that takes these images is a black and white monochrome camera, and you need to take the RGB series, in other words red, green and blue light, and combine them in the computer program to produce a colored image. Now this is an okay image. It's not great. It's just about 1 hour of total data. That includes luminous or white light. I used the hydrogen alpha for the red instead of just the red filter. Blue light and green. And as you can see, the blue is really pretty dominant in this object. It runs all the way through here. And as I explained what this is this is a curtain of material that's fleeing away from what was a supernova many years ago, probably thousands and thousands of years ago. The supernova would have been down here somewhere, and this material is fleeing out into space this way. And something noteworthy here is you can actually see this is actually working kind of like a broom, sweeping away material. If you notice the upper part of the image up here, there are many more stars and dimmer stars, and down here you can see more voids, more dark areas. This seems to be acting like a broom, sweeping away dust and gases that are in the field, and it's getting picked up in the cloud as it moves outward and clearing away. You can see actually I've got that wrong. You notice there are more stars up here, less down here. So what's happened is that the sweeping is going this way, down, not up. And you can see many more stars up here, and when it sweeps by this area down here in many thousands of years from now, it'll clear this out, and more stars that you see up here will also be visible down here. It's actually like a broom. Sorry, I reversed that at first. I got talking about it and lost my way. But it's actually sweeping downward in this frame. As I said, this comes from a supernova. Supernova are two types. There are one that are very massive stars, much more massive than our sun. And when they burn their material and reach the end of their life, and the hydrogen, the helium cycle is stopped, and they start burning heavier and heavier elements until it gets down to iron. It can no longer process iron for energy. The star collapses in the core, causing a huge rebound effect, and you get this huge supernova explosion. We've observed these, and I have too, in galaxies all over the place. Unfortunately, there hasn't been one in our galaxy, our own Milky Way galaxy, since Tycho Brahe in what was it, 1600s or late 1500s, I think is the exact year. But we're overdue to see one in our region of the Milky Way, and that would be a fantastic sight. You'd probably see, if it was relatively nearby, you'd see a star as bright as the full moon if that were ever to happen. The other type are, and I've studied both types in research, the type 2. The types 1A are the most interesting. They're a binary system, like say this star here, bright star 52 Cygni, this is actually a foreground star. It's like out here, and the nebula is back here. So that's just in line with the nebula. It has nothing to do with the nebula. But type 1A has a star here, and then it may have a very dense smaller star orbiting around it. That's what, and a duplicate star system, double star system. And what happens is the very massive star will pull material from the primary star until it reaches a point where it can no longer stay stable and the star explodes. These are stars that are very regular when they burst and go supernova. So they can be used as standard candles. In other words, they can be used, we know just about how bright they are when each one goes off because they're all about the same. So if you can study one in a distant galaxy, and I've done some of this work with photometry, you can determine the distance to the galaxy by seeing just how bright that star looks. We know how bright it is physically if you were nearby, so we can calculate how far. Well, the professional astronomers, I don't have the math skills to do this, but I have given them data for the projects. And they can determine how far the star in that galaxy, and thus that galaxy, is away by determining how much brightness a star has lost by being so far away. So they're called standard candles. And again, this object, it's been calculated to be around 1,500 light years away. That's kind of a iffy. I don't think they've actually pinned it down real close, but on average, that's the given distance for it. So anyway, that's the finished image, and again, that's only about 1 hour of data. I'd like to go out and add at least 2 more hours to it, and we can really deepen the image and get even more detail. But this is one of those objects I loved as a kid. I could never see it in my small telescopes, and here I'm imaging it with just a 4-inch telescope, 2 inches smaller than the 6-inch I used to use. But because of the modern day CCD cameras, technology and computers, look at that, a 4-inch telescope photographing an object that could only be seen by the major observatories years ago. It's a great hobby, a lot of fun, and don't know about you, but I just look at that and it's just amazing and beautiful. Alright guys, that's about it for now. I'll keep you updated as we go along. Take care.